Hi, in this tutorial you'll build a neural network from scratch and train it to make lemonade sales predictions using a simple synthetic dataset. You will be introduced to PyTorch, a deep learning library managed by Meta's own AI group. You will code the tutorial following along with me, and you have two options in terms of environment. The first option is to use Google Colab. It is by far the easiest, especially if you're new to developing AI projects. I will be using Google Colab for this tutorial. However, if you wish to run all the code on your own machine, I recommend you set up the machine using our free How to Set Up Your PC for AI programming tutorial, and then return to this tutorial afterwards. So, are you ready to build your first neural network? Then let's get started. So the first thing we're going to do is open a web browser and head over to Colab. So we're going to type colab.research.google.com. And once we get there, this is the landing page. We can change the environment a little bit to make it easier on your eyes by going into Tools, Settings, and then click Dark Mode. That's the selection that I prefer. And then we can go ahead and sign in. So you can just enter in your Google credentials. If you don't have one, you can create one at this time. Now, once we're in, we're going to click on GitHub and then type in Leaky AI and hit the magnifying glass. And then from the drop-down menu, we're going to go ahead and select First Neural Network. And then we're going to open up the Start Here notebook. So now that the notebook is loaded, the first thing we're going to do is connect it to a server inside of Google's data center and click Connect, and then wait for it to get connected. After that, you can kind of hover over that same bar and you'll see a little more detail around what kind of server we got from Google. Now, once we are connected, we can go ahead and start coding. So we're going to scroll down to this first cell. And if you're new to this notebook concept, the way we code is by clicking on the cell, entering in all your code, and then clicking on the play button in the upper left-hand side of the cell itself in order to execute the cell. Now, each cell has already been partially written, and it's your job to replace the TBDs with the correct code. So to get started, one of the first things you're going to want to do is import PyTorch, and you're going to type import torch, and then we're also going to import specifically the NN library. Next, you want to check the PyTorch version. You can do that by typing __version __, and then in order to execute a cell, we're just going to hit the play button. Now, the first time you do this, you're going to be given this pop-up warning. Just go ahead and click run anyway. Once you do that, the cell will execute and the result will be underneath it. So when we execute, at the time of this video at least, Google had PyTorch version 1.10 with CUDA 11.1. And that you can see by looking at the text right below the cell. So now let's scroll down and check what kind of CPU or GPU we have in the backend. The way we can do that is by typing torch.cuda.is available, and that will return whether or not there's a CUDA device, and we can type further torch.cuda.get device name, and that will display the actual GPU's device name that has been allocated to us. Now, when we hit run, we see that we only have a CPU device, which is good enough for this project. Now we're going to download the dataset. So the dataset here is located on GitHub, and to display the first couple of rows, we can type df.head10 and execute. Now we can see the dataset that we've downloaded. We have several columns and lots of rows. The columns are weekend, whether or not it was a weekend, whether or not it was sunny, warm, whether there was a big sign, and what the price was, and then finally the number of lemonades sold. So if we want to kind of look at the holistic data set, we can type in df.shape, and that will tell us the overall shape of the entire data set. In this case, we have 365 items with each item having 6 unique values. So let's take a look at the dataset in a little more detail. This dataset contains one-hot encoded attributes. So for example, when you look at weekend, if there's a 1, that means that on that day it was a weekend. If it's a 0, that means on that day it was not a weekend. And that's true also for sunny, warm, big sign as well. Now, price and number sold are different. They are real values, with price being the price of the lemonades that day, and number sold being the total number of lemonades that were sold that particular day. Now, the goal of our neural network is to learn how to predict the total number of sold lemonades given these other attributes, whether or not it was a weekend, whether it was sunny, warm, whether we had a big sign, and also the price that we charged. Now, before we can use this data for training our neural network, we need to standardize it. So let's take a quick pause and take a look at what standardization is all about. This data set that we have on the left is the original data set. Now, neural networks train better if the data is in the range of, say, -1 to 1. It's okay that if it's a little bit lower or higher, but usually on that range, it's good. And so if you look at the weekend, sunny, warm, and big sign, all of these, since they're 1s and 0s, are already in that range. But price and number sold are not. And so what we can do is we can apply standardization to convert the price column and the number sold column into a set of ranges that are in the order of -1 to 1. And the way to do that is using this formula, where the new value is just simply the old value minus the mean of the entire column divided by the standard deviation. So what we do is we calculate the average for this entire column, the mean, and we also calculate the standard deviation. And then we use those two values to convert this 9 to this 0.84. And we do that for all the values in the price column. And once we're done with that, we calculate the mean and the standard deviation in the number sold column, and then again apply this formula to convert these values into these values. So now we have a standardized data set. All these values are on the order of somewhere between -1 and 1. And now we can use it to train our neural network. So now let's write the code that standardizes these two columns. The first thing we need to do is to calculate the mean of the price column. We can do that by simply typing df price and then calling the mean function on that column. That will return the mean of all the values in the price column. And similarly, for the standard deviation for the price, we can access the df price and then call std, which is the standard deviation of that column. And then you see the standardization calculation next, and that's going to be applied to price. And then we're going to go ahead and do the same for the number sold. So find the mean, standard deviation, and then we apply the standardization formula to all the values in the number sold column as well. Now, after executing this cell, we can check that the values are standardized, and indeed they are. We now have a total data set that is on the order of somewhere between -1 and 1 for all the values. Now, the next step is to then carve this data set into two parts, the input and the output. The input is the weekend, sunny, warm, big sign, and price. So we can just copy that and enter them into the inputs, and then we put little quotes around them, and then the next line will basically pull those columns out and put them into a PyTorch tensor, which is kind of a generic data store for our input X. And we're going to do the same with the output. The output is the number sold, and so in the next line, Y becomes the number sold column. And we can verify that by just quickly going into and seeing the first, say, 5 lines of X, or the first 5 rows rather, and here we have them. We can see that we have all the columns, and the last one is also nicely standardized. And then the output equally is also nicely standardized. So we are now ready to build and train our network. Now, the first step in building a neural network is to kind of define the overall architecture. Now, in this case, since the inputs are 5, the neural network will have 5 inputs. And since the number of outputs it's trying to predict is 1, the number of outputs of the neural network will be 1. We are going to build a neural network that has something called a single hidden layer. This is just the layer in between the input and the output, and that will have 100 units. So let's see how we would code a neural network like this using the sequential call with PyTorch, which is one of the most simplest ways, the quick and dirty way, if you will, to quickly define a neural network in PyTorch. So let's just dive right in. The first layer is going to be called a linear layer. It's going to take 5 inputs, and those 5 are going to go into the first hidden layer, or in this case, the only hidden layer of 100. And so what you're going to see is the linear call is going to have 5 as the first parameter and 100 as the next one. Then we're going to pass the values through an activation function called ReLU. This is a little bit beyond this tutorial, but this will help us get our network really strong and capable of, say, determining non-linearities in the data, if there are any. And then finally, we're going to have the last linear layer, which is going to take that 100 and reduce it down to the 1 output. So this is the hidden 100 units going down to the 1 output unit. And that's it. We now have a very simple neural network that takes 5 inputs and goes into 100 units of hidden and then produces 1 output. So that's that number sold, the number of lemonades sold. And when we execute this, we will see the model kind of summary, if you will, and there we can verify that indeed it does take 5 inputs, converts them into 100 units of hidden layer, applies the ReLU, and then produces 1 output. The next step now is to train our neural network. Our neural network won't do anything until it's been trained on the data that we created above. And so here we need to specify 2 specific functions. The first one is how to measure how well the network is doing at predicting the results. And the second thing we need to define is the way the training process will update the neural network as we progress through the training. So these 2 things are called the criterion, which measures how the network is doing, and the optimizer, which kind of is the methodology for how we actually go about updating the weights. So for the criterion in this case, let's use a very simple one. We can type torch.nn.mean square error. This is the most commonly used way to measure a neural network's performance if it's predicting values. And for the optimizers, let's choose SGD, which is a very common optimizer. We need to give it all the neural network's weights, which is called model.parameters. And then we need to supply it something called a learning rate, which is how quickly it's going to learn from the information during the training process. And then we're also going to give it a momentum, which is a topic that's a little bit beyond this tutorial. So the next step is the training process itself. We're going to use the criterion in the optimizer, and then what we're going to do is we're going to pass in the entire data set into the neural network, and it's going to learn how to make the predictions. To begin, we perform a single forward pass. This is where we take a single piece of input data and we pass it through the neural network and make a prediction. In order to make a single forward pass, all we do is call model, which is our defined neural network, and pass it in the input we wanted to process, which is going to be X with the index I. Now that will yield a predicted result, Y pred, and now we're going to want to compare that result to what it should have been. So the value that we wanted it to be was Y I. So we need to just calculate the difference between Y pred, which is what the neural network predicted, and the actual value Y, I, index I, which is what it should have been. So that's the loss. And that loss is higher if it's further away, lower if it's closer. Next, we just kind of accumulate the loss and track that as part of the training process. We can call item to grab the value, and then we're gonna update the weights. So to update the weights, PyTorch has 3 different steps. The first one is to zero out something called the gradients from the optimizer. Then we're gonna call backward on the loss function itself, and then we're gonna step on the optimizers. These 3 commands will update the neural network based on all the information that we've just learned. So now we're ready to train the network, and what we're going to be looking for is that loss value to decrease at every iteration. And as long as it's decreasing, the neural network is starting to learn how the inputs map to the output. So let's run the cell now and then look at the results. Here we see that the first total loss was 122, followed by 11, followed by 6, 4, and then 3. So definitely the neural network is starting to learn how to map the inputs to the output. Now the next thing we want to do is analyze the network's performance. That is, how well is it able to make predictions? And the way we're going to do that is by comparing what it predicted to what it should have been. And we can plot that visually on a chart like this. So let's take a look at this visualization of the model's performance in a little more detail. At the bottom on this axis here, we have the actual number of lemonades sold on a particular day. So for example, let's take, say, this particular day here, we had about almost 200 lemonades that were sold. Now on the other axis, we have the number of lemonades sold that was predicted by the neural network. So for that same day here, that we know we had about 200, the neural network predicted maybe roughly about 170. So it didn't do that well on this particular day. However, if you look at, say, this day here, the actual value was slightly over 250, and the value predicted by the neural network for that same day was also just over 250. So it did a really good job with this particular day in terms of predicting the number of lemonades sold. So with a chart like this, the closer these dots are to this line, the better the neural network predicted the value of the number of lemonades sold compared to what it actually was. And you can see that the overall kind of theme here is that the neural network definitely started to learn how to predict the number of lemonades sold from the inputs pretty well. It didn't really deviate too much from this line. So this is a great way for you to evaluate a neural network's performance if it's predicting, say, a single value. So now as a final step, let's use the neural network to make your own predictions. In order to do that, we need to figure out what the actual value should have been. And we have access to that because this is a synthetic data set, and so there is a formula for calculating the actual value. And so the function above calculates that, and then in this section what we can do is we can specify our own values for weekend, sunny, warm, big sign, and even price, and then use our neural network to make predictions. So to get started, first we're gonna move the model to the CPU. In this section, we'll just be working with the CPU, even if we do have a GPU backend, just to make things simpler. The next thing we'll need to do is to standardize the price value using the price mean and standard deviation that we calculated above. So the way to do that is just to subtract out the mean and divide by the standard deviation. Then we will create the input tensor as we've done before, and this will be a combination of weekend, sunny, warm, big sign, and price. And so all we need to do is pass in a list of these values, and we can do that by copying the values that we passed into the dataset generator, weekend, sunny, warm, big sign and price, and then the torch.tensor will create a tensor variable that we can then use to pass into our neural network. And now all we need to do is pass x1 into our model and make our prediction, which is going to be y1. We're going to convert the input into a float. And then for the output, we need to make sure that it is unstandardized. So the way to do that is just to multiply it by the standard deviation of the num sold that we calculated above and add the mean. And now we have an ability to pass in real values that we define ourselves into our neural network and then compare them to what they should have been. So if we go ahead and run this cell now, we'll be able to see what the neural network predicted compared to what it actually should have been. And so you now have a trained neural network that can make real predictions on the total number of lemonades sold using your own inputs. There are a lot of improvements you can make to this particular tutorial, including breaking up the dataset into what we call training, validation, and testing. You can also experiment with a real-world dataset, which is going to be very different from a synthetic one. And you can also tune the training process a lot here to make it better. Congratulations! You finished building your first neural network and it was able to make awesome lemonade sales predictions. You have taken your first major step in learning how to develop your own AI projects. Next, there are lots of additional training to take your knowledge to the next level. As a starting point, consider signing up for a free email list that will alert you to some of the latest AI trends and also when new free tutorials like the one you just did become available. Finally, check out our Introduction to AI Programming course with PyTorch, where you'll get a solid introduction to how to develop your own AI projects. The course is completely online and can be completed at your own pace. Congratulations again for taking this first step. And remember to always check with us at Leaky AI for more ways to learn AI.